Hello, and welcome to this lesson on understanding domain and range. This lesson is specifically about the domain and the range of functions, identifying them. You can see here, how do I find the domain and range from a set of points, from a table, and a graph. So that's really what this lesson is about. It's focusing on just that one piece of a function that we haven't really talked about yet. Vocabulary. We did mention vocabulary when we were first talking about functions a bunch of lessons ago, but here's more specifically. So domain. The domain is all possible inputs of a relation. Notice it doesn't say of a function, just of a relation. Okay, those are typically the x values. So whatever you plug into the function, the inputs, that is the domain. The range is then all the possible outputs of a function or of a relation, and those are typically the y values. And we're looking for all possible inputs and outputs. And it's kind of different from different types of data display. So from here, like example A, we want to identify for each of these problems, to identify the domain and the range. So here, we are given 4 points. That's all we're given. We're not given any more. We're not given an equation. We're not given a table or a graph or anything. It's just these 4 points. So our domain is just what are the x values from this point, or from these 4 points. So my x values would be that. So my domain is just those values. Now I'm going to put them in order from least to greatest. -1, 0, 3, 5, and typically we would put the curly braces around this because this is a set of points. So my domain is the set of numbers -1, 0, 3, 5. It's that group of numbers. Okay, my range now will be the y values. Oopsie, wrong one. Boom, 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 boom. So my range would be the numbers, again in order, 3, 5, 6, and 7. Oopsie, that was an ugly curly brace. Okay, so it is the y values, just the y values. Okay, so that is the domain and the range. That is the only possible x values, the only possible inputs of this function based off these 4 points, and the only possible outputs of the function. Letter B. We are given this graph and it comes along with its equation. So this is the equation, the graph of y equals -2. And we want to identify the domain and the range. So this is a little bit harder because we're not just given set numbers to plug in. Here, the domain is all possible inputs of this function. So think about it, like what x values are allowed here? Can I have an x value of 0? Yeah, this exists when x is 0. Can I have an x value of 2? Yes. An x value of 5? Yes. Does the function exist when x equals -3? Yes. When x equals -5? Yes. In fact, this function will exist everywhere horizontally, because this line goes on forever and ever in both directions. So the x values here is everything, all real numbers. Yeah. Okay, that is the set of real numbers. That's what that little cursive fancy R is. It's all real numbers, meaning every single number is in the domain, everything, because this function exists everywhere. If I said, does this function exist when x equals 1,000? Yes, if I go out this way 1,000, it would exist there. Now, the range, the y values. Where does this function exist in the y values? Does this function exist when y is 0? Does it exist this way or that way of 0? No, it doesn't. Does it exist when y is 1, 2, 5. No, 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 no. In fact, the only place this exists is when y equals negative 2. So the range is just the number negative 2. That is the only possible output of this function. Now, another way that this might make more sense to you is an xy table. So we know that the xy table, all of the y values have to be negative 2 because that's the equation y equals negative 2. We've looked at this before when we graphed something like this. We made an xy table and we knew that all of those y values are negative 2, which is why the range is negative 2. But as far as the x, we're allowed to plug in any number we want. I could put in a negative 5 and a 3 and a 28, a negative 97, and a 2. Those all work, and I will get just this line. Okay, so the domain is every possible number because it exists in the x direction everywhere. The range is only negative 2 because it does not exist here, and it does not exist here. It only exists right along the line y equals negative 2. Okay, 2 more from me, and then I'm going to have you try a few. So, from this table, we would like to identify the domain and the range. The domain are the inputs, which are the x values. The range are the outputs, which are the y values. Very much like a set of points, the domain of the table is going to be just the given inputs. 4, 3, 2, 1. So I'm going to get 4. Well, I should probably do it in order. 1, 2, 3, 4. There you go. So it's just the set of points 1, 2, 3, 4. And then my range will be the set of points 6, 5, 4, 3. It's just those outputs. 3, 4, 5, 6. And there we go. So from a table or a set of points, it is just the given values. Letter D, we have another equation, another graph. So here, my domain. Based off this picture, you might think, does this function only exist from negative 3 up to positive 3? Because that's as far as it goes on my graph. Well, no, it can go farther than that. Could I take and could I plug in a negative 8 for x? Would I get a value? Well, calculator, negative 8 squared. Actually, I'm going to try to type in this whole thing in the calculator. So negative parenthesis, negative 8 squared, close parenthesis, plus 5. There we go. So there's the negative out front, the negative 8 for x. I square it, plus 5. Actually, I think my exponent's in the wrong place. Delete. Over here, second insert, squared. There we go. I do get a value. All right, so now if I would plug in something else, like does this exist at negative 100 or positive 100? Well, I can plug it in. Negative parenthesis 100, close parenthesis, squared, plus 5. It does exist. So in this problem, again, the domain is actually going to be everything. This graph, although we don't see it, will continue out, and it's going to continue this kind of, it's called a parabola shape. It's going to continue this parabola forever and ever. So it's going to exist out here at 100 and 1,000 and 10,000, but it's just going to be really, really far down below. So the domain here is all real numbers. Because again, this function would exist at every possible x value. I could plug in any x number in here and I will always get an answer. So as far as where this exists in the x direction, or maybe a better way of showing it would be Think of it like that vertical line test for functions. If I would move this line, it will always run into the function everywhere, even way out here. Now, the function might be way down here somewhere, but it will run into it. Okay? Range. What are the possible values for the range? Well, if I would look at my range, what y values does this function go through? It goes through, everything down here. Everything down here, -3, -2, -1, 0, 1, 2, 3, 4, 5, and it stops. So this function exists from, let me try to get it here, -5 and lower. It exists everywhere down here. That's kind of my range. It doesn't go above 5. So I'm going to say my range is y values less than or equal to 5. It exists at 5. If I plug in 0 for x, this piece would equal 0, y equals 5. So it exists at 5 and everything lower than 5. You could never plug in a number here and get something bigger than 5. It does not exist. So my range are all numbers that are less than or equal to 5. Domain are the possible x values. This function exists everywhere in the x direction. The range are the possible y values. It exists from 5 down. All right. Here are 2 for you to try. So go ahead and pause the video. Try these 2 on your own right now. When you're ready to continue, hit play and we'll go through it together. All right. This equation here, this letter E, is a linear function. That is the function we know y equals -1/1x minus 8. If you could imagine a sketch of this, or you don't even have to imagine, you could literally just throw this thing right in here. Clear, clear, clear. Negative x minus 8 graph. There you go. That's the cool thing about having a graphing calculator. You're allowed to use it. So you graph it on your screen. It looks like that. That kind of beats my graph a little bit. I was going to do something very similar, but like that. So what x values is this allowed? Can I plug in literally any x in here? Can I plug in 100 and 1,000 and 1,000,000? Could I plug in negative whatever? Yeah. This function exists at all x values. If you would imagine a vertical line here, it will go through every single possible x value. So my domain is all real numbers. Now my range. What y values does this go through? Will this go through, again, that -1,000? Will it go down here through -1,000? Yeah. Because this line it goes on forever. So this line will go on forever and ever and ever. It will go through every single y value. So my range is all real numbers as well. And for the most part, that's going to be true. Anytime you have an equation slope-intercept form, it will go through all x's and all y's because it's linear. And as long as it's slanty, as long as it's not a vertical line or a horizontal line, it will eventually go through every single possible x and y value. Okay, for letter F. Hopefully you said your x values are the x values that are greater than or equal to 2. And the y values are all real numbers. So the x values only exists from here over. They do not exist. There is no 1, 0, -1. It's only x values greater than or equal to 2. So from 2 over, it's good. As far as your y values, this line will continue to go up, 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 up and down, 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 down. Go ahead and pause the video and try these two as well, letters G and H. When you're ready to continue, hit play, and we will go through it together. All right, so letter G is just a few set of points, so the domain should be just boom, 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 boom in order. -8, -6, -4, -2. Hey, it was already in order. Our range is going to be just the Y values. 3, 4, 5, 6. Also already in order. 3, 4, 5, 6. And there we have it. So that one was fairly straightforward, fairly easy. Just the given values is the X values are our domain. The given Y values were the range. Letter H. I like this problem because it's a good example of domain and range. Okay, so the domain, again, are your X values. This function here exists only from here to here in the X direction. So what X numbers does it go through? Well, there's 0, 1, 2, 3, 4, -2, -4. So this function exists from -5 through roughly +4. But you got to watch out a little bit, some inequality stuff, like here, solid dot means it actually does go through -5, so we need, we can write this a few different ways. We could say X is greater than or equal to -5, and X is less than 4. We are not saying less than or equal to because it's not equal to 4. There's a hollow dot here. So we can say that, or we could also say X is greater than or equal to -5 and less than 4. These are both equivalent. I'm going to change the color of this one. They are equivalent. This is a compound inequality. This is not a compound inequality. A lot of students find this easier to write at first, but eventually you should move to this notation if you can. I remember this because it's always smallest, middle, largest. So the smallest number, the -5, came first, the 4 comes last, and it's always like -5 is less than X is less than 4, sort of thing. Okay, so this only exists in the X direction between -5 and +4. So now let's talk about our range, our Y values. Our Y values only exist between here and here, only in that range. And that is the range, let's see, 1, 2, 3, 4, 5. So it only exists between roughly 3 and 5. So it is from Y values that are less than or equal to 5, because this is the or equal to the solid dot, and what did I just write? And Y values that are greater than 3. So from 3, not equal to, because it doesn't go through the point, it's not a solid dot, from 3 bigger up to 5, and that's it. That's the whole thing. It does not go anywhere else than that. And again, you could have the compound inequality. If I can zoom in, that would be Y is greater than 3 is less than or equal to 5. These two are equivalent. Most mathematicians will do this. This is what you'll see in a textbook and an answer key and tests and stuff. But this is a little bit easier to understand when you're first getting started with compound inequalities. So that one was a bit of a challenge. And maybe if you weren't able to write it the right way, you still had the right ideas. It only exists between here and here. If you understand that, then you've already got the basics. It's now just the practice of writing it and getting the notation right. And that's really what this lesson's about. Okay, so you've done the past 4. I'll do these 2. If you want to do them on your own, I encourage you to pause the video and try them on your own first. But if not, I'm going to do them right now. So the domain here is just the number 4. 4, 4, 4, 4. The only possible input, the only input given is the number 4. So that's my domain. My range are the numbers 22, 33, 44, 55. It's just those 4 numbers. All right. Letter J. My domain, my x values, it exists from here the whole way to here. It doesn't exist outside of that. It does not exist bigger. It does not exist smaller. It's between there and there is my domain. It's my x values. And that is 0, 2, 4, 6, -2, -4. All right. So I'm existing. The domain is existing from between -5 and +6. Everywhere. I mean, it exists here, 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 here. You might go, wait a second, there's a hollow dot. Yes, but there's a solid dot right below it. So it does exist at -1 because of the solid dot. Same, 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 same. Boom. Same, 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 same. So now, if we're doing our compound inequality to make this, slightly better, all we need to do now is get the right types of symbols between here. So, at -5, it is equal to that point, so I'm going to make sure that this is a greater than or equal to. It exists greater than or equal to -5, and it exists less than, not or equal to, 6. Solid dot at -5, hollow dot at +6. Range. Range is a little bit trickier beast to deal with. I'm going to actually leave him because I like that. So my range, it does not, we could not say it exists from here the whole way down to here. It doesn't. It does not exist at 1 or 0. It does not exist at 4 or 5. Or whatever those numbers are. Okay? It doesn't. It only exists on this line when y is -1. It exists on this line when y is a +2, and exists on this line when y is 2, 3, 4, when y is equal to 5. So my range is going to be just literally those 3 numbers. That is the only y values where this function exists. So it is just the range of -1, 2, and 5. So my domain exists from -5 to +6, and the range is just the values -1, 2, 5. It is just those 3 values. It does not exist anywhere else in between here, above there, below there, nowhere. Just those 3 values. Okay. A little bit of problem solving. And all of these problem solvings relate to the questions we've already done. So question A here says, do the domains of the relations below have any shared values? If so, what are they? Do the domains have any shared values? So we said here, this domain was 4. Does this guy have a domain of 4? Question mark. Does it exist when x equals 4? 0, 1, 0, 1, 2, 3, 4. Why, yes, it does. This one, they share a domain value of 4. This exists at 4. Do they share any values? Yes, when x equals 4. I don't think we need braces around that one. That is the one point that they share. They don't share anything else. He only exists at 4. He exists at more places, but they share the number 4. It's just the x values. That's the domain. Letter B. Explain why these two relations have different domains, but they have the same range. So different domains, same range. So it's saying their sets of x values are different. This one, the domain is all real numbers, and the range is all real numbers. So this is that linear function. In fact, I still have it here graphed. This will go through every x value left and right and every y value up and down. This other one here, if I change color, its domain is from x values greater than or equal to 2, and its range is all real numbers. It will eventually go through every single number vertically, so it'll go through 1, 2, 3, 4, 5, 6, 7, 8, 9. It'll be very far over to the right, but it'll go through every single number, 1,000, a million, a billion, a trillion, all of them. So explain why these relations have different domains but the same range. I would say the domain of the first one is all real numbers. The domain of the second one is just x values greater than 2, but they both share a range of all real numbers. Both of these functions will go through every single possible y value. I'm not going to write that out because my handwriting is sloppy and you don't need to see me write out that explanation. If you'd like to write it out, I encourage you to maybe rewind the video and pause it step by step to hear my words again. But they share the same range, all real numbers, but their domains are different. This one goes through every possible x value. This one only exists when x is greater than or equal to 2. All right, letter C. I would like you to pause the video and try this problem on your own. When you're ready to continue, hit play, and we'll go through it together. All right, so using a set of points, a table, or a graph, make a relation that has a domain of 2, 4, 6, and a range of -3, -4, -9, -15, and -18. Would this relation then be a function? So I'm going to make a table. I like tables a lot more than most students like tables. So x, y, 2, 4, 6. And so now, I mean, I have to use all 1, 2, 3, 4. I have to use all 5 of these numbers. There's no real special trick to this. I mean, yours may not look like mine. I'm going to start off -3, -4, -9. Now, I kind of have to reuse more x values, don't I? I mean, I can't just stop here. I have to use these other ones. So, I mean, there's another 2 and another 4. Sure. And then -15 and -18. Why not? So now I've used 2, 4, 6, 2, 4, 6, 2, 4. I've used all 5 of my range values, -3, -4, -9, -15, and -18. So I've done the first part. Would this relation be a function? No, it's not. There's no way yours could be a function because you're going to have to reuse an x value on 2 different y values. Here, I did it with 4 there, as well as with 2 there. So I have one x value, 2, with 2 different y values. That would fail the vertical line test. So this would not be a function. It is still a relation. It still has a domain and a range, but it's not a function. It does not pass a vertical line test. Each input does not have exactly one output. Letter D. Which relations below have the same domain? Select all that apply. All right, that's kind of an interesting question. So domain, I'm looking for the x values. Well, relation 3, its domain is just the values in order 5, 6, 7, 8. That's the only possible x values, the only possible domain. relation 2, I can tell that I can solve this into slope-intercept form, y equals 2x plus 4.5. And like I told you before, any equation in slope-intercept form will go through all possible x and y values as long as it is not a vertical or horizontal line, and this is not. So this guy has a domain of, we're talking about just domain here, it has a domain of all real numbers. 1. Relation 1. Range. I'm sorry, domain. Just domain. This will eventually extend out to all possible x values. It exists at 1, it'll exist at 2, you could imagine it'll keep going out, it'll exist at 3, and 4, and 5, and 6. It'll be very, very tall, but it will exist. Just like it'll keep going through -3 and -5. It'll be very, very low, but it does exist. So this has domain values of all real numbers. In fact, its range is also all real numbers. These two share the same domain and range. But as far as the question goes, which relations share or have the same domain? It's relations 1 and 2. They both have all real numbers as their domain. Summary. So in your own words, describe how you find the range of a relation. And feel free to talk about from a graph, from a table, from a set of points, from an equation. How do you go about identifying the range of a function? Pause the video and answer your question, and then when you're ready to continue, hit play, and we'll go through it together. All right, so I'm going to kind of talk about each of them. So from a table perspective, the range is just the y values that are listed. So any of the y values are listed, that would be the range. The same thing is true with a set of points. The range would be just the points that are listed. So those are the only points that were listed in my range, so those are the only possible y values that we know of. It's a little bit different when you're talking about an equation or a graph. An equation, a lot of times our best bet is to actually graph it. When we've graphed the equation, the range is then all of the possible y values, like here. And a lot of times it's good to imagine it going through each of the points and how far up and down does it go. That would be our range. Okay, thank you so much for watching. I hope you learned about domain and range. Until next time, toodles.